All right, this is part 2 of our unit lesson 6.3. So now we have this beautiful unit circle. And again, there's really only 5 numbers to remember. And if you can remember those numbers, then you're golden. So let's figure out how we use the unit circle. So again, I'm starting with an example 1 here. Given the following unit circle, so they're giving you a unit circle, rotate the green dot to the appropriate angle, then find the exact value of the function cosine of 150. So I'm always going to start with a problem you're going to see. This is the problem. So where is 150 degrees? So you get to rotate that angle. I'm going to use green. 150 degrees. So that would be 30, 60, 90, 120, 150. Lands about right here. So you would get to rotate that green dot. So you click and drag it around till about 150 degrees, which is about right there. So there's our little 150 degree angle. And what we want to do then is draw our little triangle. Well, there's our little reference triangle, always to the x-axis, right? You drop your altitude. And what we've created is a little 30-degree reference triangle. And what are the side lengths? Well, this x side length here, we know, is negative radical 3 over 2. That's that longer leg. And then that shorter leg is a half. We also happen to know that this is the unit circle, so it has a hypotenuse of 1. And so if we want to know what's the cosine of 150 degrees, well, cosine would be adjacent over hypotenuse. And I can see that the adjacent side is negative radical 3 over 2. And the hypotenuse is 1. Well, so that's just negative radical 3 over 2. That's the answer we're looking for. So let me give you the shortcut. The ordered pair for this 150 degree angle from our unit circle was negative radical 3 over 2 and up a half. That was the ordered pair. The beauty of the unit circle is that if you know the ordered pair, then the cosine of 150 degrees is just the x coordinate. And the sine of the angle is the y coordinate. Now, why is that? Well, it's because the hypotenuse was 1. And so when we do this adjacent leg, the x value divided by the hypotenuse, when we have a hypotenuse of 1, it doesn't change anything. All right. So you can do it either way. You can draw the triangle and do your little ratios. It's really easy to do. Or you can just use the x coordinate, in this case, because we want the cosine, and you're done. So lots of options here. And again, I will do both. So letter B, draw the angle, then find the sine of 330 degrees. So I love that they make you draw the angle on these because I think that's fantastic. So 330 degrees. Oh, let me draw it. Oh, yes, I won't. I'm going to fake my circle. There we go. It's not. I sometimes do really good circles, but 330 degrees is 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, and then 330. So initial side, opening all the way around, we get our terminal side at 330 degrees. So there's our angle theta. And if I were to drop my little altitude, then I can clearly see that I have a little 30-degree triangle, little 30-degree reference angle here, which means this, I have a long leg of radical 3 over 2 and a short leg that's going downward, so negative 1/2. And of course, this is the unit circle, so I have a hypotenuse of 1. So if I want to find the sine of 330 degrees, well, that would be opposite over hypotenuse. So we use the little reference triangle here. That's the triangle that you see. And you always use the angle closest to the origin. So the opposite side would be this -1/2 divided by the hypotenuse of 1. Oh, so that just equals -1/2. Using the unit circle ordered pairs, I know the ordered pair was radical 3/2 down 1/2. Well, it goes cosine sine, so we just take that y coordinate. So the sine is always the y coordinate. Cosine is always the x coordinate. That's kind of handy, right? So either way, you can just draw the ordered pairs. It's alphabetical, cosine before sine. All right. Or you can do the little trig ratio, however you want. Let's try some more. Ooh, tangent. How do you get a tangent? All right, so I'm going to draw my little circle. Yeah, I'd like to draw little circles. I make all my students show me the little circles, circles and dots, that's what I call it. Tangent of -45 degrees. So this is a negative angle, which means we have our initial side on the positive x-axis, and we're just opening downward, so clockwise. So right here would be -45 degrees. So there's my -45 degree angle, and we know it's a 45, which means, what is this ordered pair? Oh, let me not do the ordered pair yet. This is a 45, 45, 90, so these have the radical 2s. So this is radical 2/2 to the right and negative radical 2/2 downward with a hypotenuse of 1 inside that unit circle. Very cool. So if we want to do the tangent, my triangle is a little bit too small, I fear. Let me see. So I'm just redrawing it. So here's our little -45 degree angle. Radical 2/2 and negative radical 2/2 and the hypotenuse of 1. Okay, so if we want to do the tangent of -45 degrees, then that would be opposite over adjacent. So looking from this little angle right near the origin, the opposite side would be negative radical 2/2, and the adjacent side would be positive radical 2/2. And well, radical 2/2 divided by radical 2/2 is 1. So this is -1. How do you get that using the ordered pairs? So I know that that ordered pair right there on my unit circle is radical 2/2 and negative radical 2/2. It turns out that what we just did, the opposite side was really the y coordinate. And the adjacent side was really the x coordinate. So if you want to do the tangent ratio, it's really the y coordinate over the x coordinate. And you'll get the same thing. That's what we're doing here. This is the y coordinate divided by the x coordinate. All right. So tangent is y over x using the unit circle. All right, let's try another one. So circles and dots here. Oh, that's a good circle. There we go. 210. So that'd be 30, 60, 90, 120, 150, 180, 210 right here. So here is my lovely angle that opens in the positive direction, 210 degrees. When I drop my wee little altitude, again, it's kind of small. I hope you can see it. Okay. When I drop my little altitude, I see my lovely little triangle. That's definitely a 30, 60, 90 shape. So I know that this x side is in the negative direction, negative long leg, negative radical 3/2, and then the y is -1/2. So my ordered pair would be negative radical 3/2, -1/2. So if we want to do the tangent of 210 degrees, well, that would just be our y coordinate over the x coordinate, which would be -1/2 over negative radical 3/2. Again, we're looking from this angle really close to the origin here. So it would be opposite which is that negative a half. So opposite over adjacent. And the adjacent is negative root 3 over 2. So how does that work? How do you clean this up? First of all, I know it's positive. Negative divided by negative is positive. We have 1/2 divided by radical 3 over 2. So I'm going to write it this way because I don't like dividing by fractions. Instead, I'm going to multiply by the reciprocals. So we're going to keep change flip. Multiply by 2 over radical 3. What happens? Well, those 2's just cancel out. So there you go. When it's in fraction form like that, the denominators just end up canceling out. So we're left with 1 over radical 3. And then I can rationalize. So I'm going to multiply top and bottom by radical 3. And that's going to give me radical 3 over 3. Okay. Oh, 90 degrees. This is a quadrantal angle. So again, I'm going to go ahead and draw my little circle with dots. So starting at 0, opening up 90 degrees, there is my lovely little quadrantal angle. Now, when you have a quadrantal angle, there's no triangle. You have to use the ordered pair. So what's the ordered pair here? Well, 0 for x, 1 for y. So what's the sine of 90 degrees? Remember, cosine sine, it's just the y coordinate. Pretty handy, all right? Cosine sine, the sine is the y coordinate. All right. So another one, 270 degrees. Here's 0 degrees, 90, 180, 270. So here is our 270 degree angle opening all the way around. And again, it's a quadrantal angle. Its ordered pair is 0, down 1. So if we want to do the tangent of 270 degrees, again, there's no triangle to draw necessarily. So we just think that tangent has to be opposite over adjacent, which normally would turn out to be the y coordinate over the x coordinate. So in this case, it'd be negative 1 over 0, which, when the 0 is under, it's undefined. Okay? You cannot do the tangent of 270 degrees. Now, the nice thing is all of these you can double check on your calculator. Of course, Delta Math is going to want exact answers, but if you go to your calculator and change the mode, make sure that you're in degree mode. So you just move Tinkerbell, move the cursor there and hit enter. Then you can type in and do the tangent of 210. Tangent of 210 is 0.577. You could never give Delta Math that answer, but you can double check your answer. Radical 3 divided by 3 is the same thing. So you can absolutely do that. You can also try the tangent of 270 degrees is domain error, not possible, all right? It's undefined. So we can't do that. That's why it's undefined. Doesn't exist. All right. So let's look at our reciprocal function. So I have a lovely 5, 12, 13 triangle. You can see I have labeled A and B. These are the reciprocal functions. This is cosecant. Cosecant is spelled C-O-S-E-C-A-N-T, cosecant. This is the cosecant of angle A. Cosecant is the reciprocal function of sine. So reciprocal just means it's 1 over that thing. Here we have secant, again, S-E-C-A-N-T. All right, secant of angle A is 1 over the cosine. And this is cotangent. That one's easy. Cotangent. Cotangent of angle A is just 1 over the tangent. So how does that work? Well, let's see. If we want cosecant of angle A, it'd be 1 over the sine. And sine, we know, is opposite over hypotenuse. Well, I don't like dividing by a fraction, so we're going to keep change flip. Keep the 1, multiply by hypotenuse over opposite. Oh, so cosecant is really hypotenuse over opposite. So all we have to do is flip the sine ratio, which would be, in this case, looking from angle A, the hypotenuse is always 13. The opposite side of angle A would be 12. And that's it. So secant of angle A is the reciprocal of cosine. Now, if cosine was adjacent over hypotenuse, then secant's going to be hypotenuse over adjacent. And you can go through all the math if you want, but it's just unnecessary. So secant is going to be hypotenuse over the adjacent angle to A would be 5. Cotangent of A, if we know tangent is opposite over adjacent, then cotangent is going to be adjacent over opposite. So the adjacent side is 5 and opposite is 12. So 5 over 12. And that's it. So if you know sine, cosine, and tangent, the reciprocal functions just reverse, or not reverse them, but flip them. So you'll notice that cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. Now that one's easy. That sort of makes sense. But what you'll notice is that each of these has a C, an S, and a C, an S, and a C. So you never put secant with sine. Those don't go together. You need an S and a C, S and a C. And then tangent and cotangent just go. So cosecant, now we're looking from angle B. So I'm going to change colors here. I'm going to use red. Okay, so now we're looking from angle B right here. Cosecant is the reciprocal of sine. We know sine, toa. All right, so if I know that sine is opposite over hypotenuse, cosecant is going to be hypotenuse over opposite. Looking from angle B, hypotenuse is 13. The opposite side of angle B would be 5. Secant is the reciprocal of cosine. So that's going to be hypotenuse over adjacent. So the hypotenuse is 13. The adjacent side to B is 12. Cotangent is the reciprocal of tangent. So that's going to be adjacent over opposite. So that's going to be 12 over the opposite 5. And there you go. So now these are the big 6, all 6 trig functions. Sine, cosine, and tangent, those are the big 3 you absolutely have to know. And then cosecant, secant, and cotangent you can get just by flipping those ratios. So let's try it. Ooh, this is a little different. Let's try some more stuff here. This goes back to just drawing. So an angle theta in standard position and 4, -7 is a point on the terminal side of theta. So that's really important. They're telling us that 4, -7 is a point on the terminal side of angle theta. So we want to move the yellow point to visualize the problem. And so we want to move this this yellow dot, and we're going to move it to 4, -7. So that means we're going to move this open up angle theta all the way around to 4, -7, which is right here. So that's the point 4, -7. And that's a point on the terminal side. So I get to draw my terminal side. So that's the angle. It opens all the way around and passes through that point 4, -7. What happens when we do this is I can drop my little altitude. There it is. And you can see now, here's our big giant angle theta. We've created this little reference triangle, and it has a side length of 4 and a long length of -7. And that gets us 4, -7. That gets us to our point here. So the question is, we have to find the cotangent of theta in simplest form. Well, in order to do that, this is not on the unit circle. Our unit circle has a radius of 1, right? All right. So this is way bigger. way bigger than a unit circle. So we actually do need to know this third side. So we need to find the third side in this triangle. And to do that, we can use the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. So that's a squared plus b squared equals c squared. And let's take, here we have 4 squared plus negative 7 squared equals our hypotenuse squared, this third side. 16 plus 49 equals c squared. And remember, negative 7 times negative 7 is positive 49. That's going to be 65. I better double check my math here. Hold on. 60 plus 49. 65. Okay, good. And then we can take a square root of both sides. The nice thing is your hypotenuse has to be positive. It's a radius of a circle, so it always has to be positive. 65 is 13 times 5, so I can't simplify it. So I'm just going to leave it radical 65, and that's our third side. And now we get to figure out, well, what is the cotangent of this little reference triangle that we've drawn? So again, we're always using the angle closest to the origin, and cotangent, so SOHCAHTOA, so that's going to be adjacent over opposite. So adjacent, oh, I didn't even need the third side for this. Oh, well. The adjacent side then would be 4, and the opposite side would be negative 7. Man, that was just a coinkydink. But if I'd asked you, hey, what's the secant of theta? Well, secant would be hypotenuse over adjacent. And so that one, the hypotenuse would be radical 65, and the adjacent side would be 4. Okay, so just to give you an idea, and so that is, we're using the triangle, not really the angle that we've drawn, but the triangle that we create to find those ratios. All right, we have a few more of those, I think. Yeah. These are my favorite. I think they're super cool. So I'm just going to make a sketch of this. Negative 2, 5 is on the terminal side of angle theta. So negative 2, 1, 2, 3, 4, 5. So right there is the terminal side of angle theta in standard position. So here is angle theta, and it's in standard position, and it passes through negative 2, 5. So all I have to do is drop my altitude to create my little reference triangle that we can use to find ratios. So I know that this side is negative 2, and the hypotenuse, the long leg is 5. So once again, I need to figure out that hypotenuse, because once again, this is not a unit circle. So let's see, leg squared plus leg squared equals hypotenuse squared. So that's 4 plus 25, which would be 29. Square root, and I can't simplify it. So that means this third side has a length of radical 29. And now I can find the cosine of my little reference triangle, which is the same as theta, has the same ratio. So cosine, using this little green angle, looking from this angle, would be adjacent over hypotenuse. So that's negative 2 over the hypotenuse of radical 29. And of course, they are not going to like that. So we're going to multiply top and bottom by radical 29. And I can't simplify that at all, so I just made these up. Delta math might make you simplify. 29 is prime, so I can't take square root. So there we go. One more here, just for giggles. Yes, this is the last one. So make a sketch. Negative 3, 1, 2, 3, 4, 5, 6. There we go. So negative 3, negative 6 is right there, and it's on the terminal side of an angle theta in standard position. So initial side, terminal side, and here is that angle theta. Big angle. So we're going to drop an altitude. Remember, altitudes go to the x-axis, nowhere else. Never draw to the y. Because we have to create this little reference angle, which is always between the x-axis and the terminal side, not between the y-axis and the terminal side. So always here. And you can see then that we have a side length of -3 and this longer leg of -6. We need the third side. So -3 squared plus -6 squared equals our hypotenuse squared. 3 squared is 9, 6 squared is 36, and that would be 45. We can take a square root of both sides, and that does simplify. 9 times 5, the square root of 9 is 3, so 3 radical 5. Again, it's always positive on the hypotenuse. So now we want to find the cosecant of theta. Cosecant is the reciprocal of sine. Sine is opposite over hypotenuse, so this is hypotenuse over opposite. So that would be 3 radical 5. Looking from this angle, and the opposite would be -6. And I can see that I can reduce my 3 and my 6. So I divide by 3, that turns into 1 radical 5, and here we get -2. So negative radical 5 over 2 for our cosecant ratio. All right, ladies and gentlemen, that is it. I'm sorry it was a long day, but it always is for the unit circle. Here you go. You can now do lesson 6.4.